0 exponents. So that means the exponent, the small number, is going to be a 0. So let's just take a look at what that would look like. For instance, let's say I have the number 5 raised to the 0 power. So if we think about that for a second, that's a little bit weird because 5 raised to the 0 power kind of you think it's 5 times 5 0 times. So that should equal 0. However, when you evaluate this on your calculator, it equals 1. So that's kind of weird. So I want to try to explain why that is. So if we look at repeated examples, there's a couple different ways we can kind of explain how this works. So let's just look at powers of 2, okay? And this will help us talk a little bit about negative exponents as well. So in this part, I'm just fast forwarding, making the table to save some time. Okay. And if you see in this table, as we go from left to right, all these numbers are being multiplied by 2, okay? So one would think if we go the other direction in the table, okay, if we go to the left, what's happening? Well, we're going from 16 to 8 to 4 to 2. It looks like it might be subtraction, but it's not really subtraction. Everything's being cut in half. So we're dividing by 2 when we go in this direction. So that leads us to this previous column in this table, okay? Obviously, this is going to keep going like this forever, okay? Let's go back the other direction. So now, before 2 to the first power would be 2 to the 0 power. All right, now if we follow our pattern, it can't equal 0 like we think it should. It actually has to be 2 divided by 2 because we're dividing by 2 going this way. Well, 2 divided by 2 is 1. So that's one reason why something to the 0 power is 1. Now this works for powers of 2 or powers of 5 or any base. It's always going to be 1. Okay, the one exception is if you have 0 to the 0 power. Well, you can't evaluate that. Okay, so the property basically says any non-zero number raised to the 0 power will be 1. So this is the property. So basically anything to the 0 power is